Hello everyone and welcome to the channel of Illuminate Education System. So in this video, we're going to be looking at chapter number 1, which actually is not exactly chapter number 1 according to the O-levels chemistry syllabus, but it's actually the last chapter, but we're looking at it first because as we said, we are going to look at each and every single component of the syllabus in a way that it gets from the graph of easier to medium to difficult. So we are first going to look at the easier things and that will help us to gain a basic base of chemistry on which the other topics are based as well. So beginning with chapter 1, experimental chemistry. First, let's know about the fact that what even is experimental chemistry. So, scientists find out about the nature of materials by carrying out experiments in a laboratory. And a knowledge and understanding of the correct use of the scientific apparatus is required for successful experimentation and planning investigations. And this knowledge is basically known as experimental chemistry. So, as the first thing that comes in your mind whenever you talk about chemistry, uh, you must have just have the idea that you're in a lab with a lab coat perhaps on yourself, and you're just carrying out and conducting some experiments, and that basically is actually the part which links itself to experimental chemistry, because chemistry is not entirely all the lab work. It's basically understanding the nature of how matter works, but experimental chemistry is the part in which you really can say that yes, you're going to work in a lab. And that's specific if you're giving the paper 3 of the O-levels chemistry 5070, which is a practical examination. And if you're in some countries such as Pakistan, you may be giving the ATP, which is the P4, or the alternative to practical, in which you basically perform whatever the syllabus objectives and assessment objectives are. You basically just write them on paper instead of actually doing the practical. So experimental chemistry mostly comes in ATP, the paper 4, which is the alternative to practical. And let's just get into it. And today we're going to be looking at the chapter of measurements, the specific subtopic of measurements. That's what we're going to look at today. In the chapter of experimental chemistry, we'll be looking at purification techniques and other stuff such as the gas and flame test and the identification of ions and gases later on. So beginning with measurements, first we're going to look at the measurement of time. So in time, we'll be looking at the importance of time, the units of time, and the apparatus. So we're basically going to be looking at the importance of the measurement, each measurement we're going to be looking at. Then we'll be studying about the units, how we measure those things in the actual scale, and the apparatus which we use to measure. So apart from time, we will use looking at the measurement of temperature. Then we have the measurement of mass, and finally the measurement of volume. So, looking at the measurement of time, what is time? So, time is the measure of the rate at which things happen, although a fixed and proper definition is still a mystery. If you're an enthusiast of science and you like to do a bit of research here and there, such as me, so you must know that time is one of the most confusing aspects of the reality. And even though that's something you should look at yourself in your spare time whenever you're trying to do research, which is recommended. But in our syllabus, time is simply the measure of the rate at which things happen. And because of that, we'll be looking at the chapters such as the rate of reaction and other chapters in which we'll be basically looking at time as the measure of the rate. The rate of change at which things are, turning from one form to another, from reactants to products. That's what we're going to be looking at according to time. So time is usually measured in hours, minutes, and seconds. And time is usually measured by the instruments such as stop clocks and stopwatches. And even though there are other units of time, which are macro and micro, such as milliseconds, there are even microseconds, and you can go up to years or maybe centuries or millenniums. But hours, minutes, and seconds, these are basically the most average versions of the measurement, and that's what we're going to be looking at the past papers as well, and the mode at which we'll be working. And this in duration of time is can only be measured by stop clocks and stopwatches, and they're nearest to 0.01 seconds as written in here. So whenever, for example, you look at the stopwatch such as this, so you can see here that it's kind of showing 41 seconds and 91 milliseconds. So here we are nearest to 0.01 second, and that's basically an explanation of just the accuracy of the instrument. Then we have a stop clock, which is simply an analog version of the same digital clock. So moving on, Time is an important measurement in chemistry because it allows scientists and chemists to record and measure the rates of reaction, as we discussed before, and provide analytical information about how fast or slow reactions form products with different factors, which are usually expressed on graphs. So basically, this is the application of time we should be looking at in our syllabus, and which we will be solving questions of. Moving on to the measurement of temperature. So, what is temperature? Temperature is a measure of how hot or cold a substance or material is, as you must have already known. On the quantum scale, which simply means on the particular scale, the scale at which the atoms interact, it is the measurement of how fast the particles are moving in a system. And it is usually measured in Celsius, which is degree C, and Fahrenheit, which is expressed as degree F, and Kelvin. However, mostly we'll be using the degree Celsius scale in our questions and syllabus. So I'm talking about time again. There's just fixing in my mind. Anyway, temperature can be measured using thermometers, which are mercury in glass thermometer and alcohol in glass thermometers. So as you can see here, this is the mercury in glass thermometer, which you can see the silvery liquid inside here. That's mercury, and this is the alcohol in glass, in which you have ethanol, which is basically colored red, so that you can actually see that. And these are the two types of manual thermometers. There are also digital thermometers, but we're not going to look at that in a lot of detail. So temperature is often an important measurement in chemistry, and it's used in various experiments, such as we'll be looking forward, like distillation, fractionating columns, and the rates of reaction, in which the measurements of temperature are really essential to us. So moving on to some of the differences between the mercury in glass and alcohol in glass thermometer. These should be handled carefully, specifically the mercury in glass thermometers, because the mercury inside them is toxic and poisonous. So that's one of the precautions, that you should handle that carefully. Maybe use some gloves to prevent, in case you spill the mercury inside, to prevent any corrosive effect. And in alcohol in glass thermometers, it's easier to handle, because if even if the thermometer breaks down, the alcohol inside is harmful, and you can just wash it away. So the mercury in glass is basically suitable for measurement of high temperatures, such as here's the range we're given, minus 37 to 356. And why are we given this range? Because the melting point of mercury is minus 37 degrees, which actually is the point where it turns from solid to liquid, and the boiling point is 356. So as you can see, 356 is quite a high temperature, and that's why we can use mercury for high temperatures. However, the alcohol, its melting point is quite low compared to mercury, and its boiling point as well. So that's why we can use it for the measurement of low temperatures, such as less than minus 37. So both of these have different ranges according to their melting and boiling points. And even though you're not required to memorize these, it's better if you know that. So mercury in glass thermometers are highly durable because mercury does not evaporate or stick in walls of thermometer. And the reason for its durability is because it's kind of a liquid that does not, it's not volatile and stuff like that. However, alcohol evaporates quickly, as we know that it has low boiling point. So if you expose it to, really high temperatures, and even in some places on Earth, there are 50 degrees, which is quite close to the boiling point of alcohol. So it can evaporate easily, and the thermometer is rendered useless after that, and can also stick on walls of thermometer. So that's one of the drawbacks of the alcohol in glass thermometer, in which mercury in glass can be a good replacement. So finally, alcohol. One more fact you need to know about alcohol in glass thermometers is that alcohol is colorless and needs to be dyed before being used, which is usually red, as we discussed before. And there's not a need in mercury, because it's actually a silver metal, which is in liquid state. So here are some of the precautions and things to remember while measuring temperature. So when measuring a temperature with a mercury in glass or alcohol in glass thermometer, the scale will usually be in 1 degree intervals. So it is possible to read to the nearest 0.5 degrees as the general rule of accuracy, as well if the reading is between 2 marks. So what we basically mean here is that, for example, here we have a thermometer, which looks like an alcohol in glass thermometer because of the red line. So if you try to measure, it's here 5, 6, 7, 8, 9. So actually, as you can see, it is nearest to the 1 degree interval. As we discussed before, the scale is usually in the 1 degree intervals. So as you can see, the intervals 5, then 6, then 7, then 8. Basically, these scales right here, they are 1 degree apart, and that's why we can measure closely to the 0 0.5 degrees as well. For example, if this red line could have been halfway between 9 and 10, so we could have said that it's 9.5 degrees. And that can actually be accurate as well because it's exactly halfway between them. So, like in every measurement, parallax and visual errors must be avoided while reading temperature from a thermometer as well. So, to fix that, we position the eye straight in front of the level of the liquid meniscus to get an accurate reading. As you can see in this diagram, if you look at this from above, you may get the reading a bit lower than it actually is, and from the below, if you watch it from below, it may be higher than it actually is. However, if you place your eye perpendicular to the meniscus or perpendicular to the entire thermometer, then you get an accurate reading, which is 19 degrees in this case. So if the level of the eye is below the level of the meniscus, you will get a higher rating, and the level of the eye is above, you will get a lower rating, as we discussed before. So measurement of mass. What is mass? So just like we looked at definition before, let's look at the definition of mass. Mass is simply the measure of amount of matter present in any substance or material, and it is usually measured in grams, kilograms, and milligrams. As we all know, whenever you're going out, just weighing the groceries inside the supermarket, it's usually measured in kilograms and so on. In grams, you can have some, medicinal tablets and stuff that's measured in grams, and milligrams. You can use any example from your life. But basically, mass actually means the amount of atoms, particles, ions, or whatever molecules in a substance. Is basically is a way of counting how many of those stuff is present inside any specific material. So that's basically mass. So here are some of the conversions we should look at. The most important one is the 1 kilograms to 1,000 grams. That basically means that inside 1 kilogram, we have 1,000 grams of mass. And mass can be measured in a laboratory using many different electronic balances, and such as these ones. So whenever you're trying to measure the amount of reactants, and for example, if you're measuring the rate of reaction between a gas, so basically a reaction will be happening here, which will be, for example, let's say 10 grams, and then some of the gas such as CO2 is produced. So the mass will be reducing, and that's why the measurement of mass is really important when we are looking at chemistry. This is another sort of electronic mass in which it is covered from all sides. This usually works when we have to prevent any of the reactants spilling out, or we're using with a corrosive or toxic or poisonous gas such as chlorine. So there are different types of masses for different types of applications. And as we said before, that mass is a significant measurement when it comes to chemistry because it tells us the amounts of matter in a substance. And thus, it can also be useful to calculate the concentrations, MR, moles, and other important quantities used in chemical reactions, which we'll be looking in the upcoming topics and in the upcoming videos. And it is also important to know how much of an substance is reacting in, we're looking at concepts as limiting reactions, excess, and mass will be an important measurement there. So there are some things such as, like we discussed in temperature, there are also some things to remember while we measure mass. So the precision of any electronic balance is the least amount of mass it can measure on a display. Exactly the stuff which you looked at the stopwatch, it was closest to 0.01 seconds. And similarly, the mass, the electronic mass balance, it should actually usually, just accurate to 0.01 grams or precise. So as you can see here, here we have 504.0 grams, even though we do not have a visual representation of 0.01 grams accuracy here. But still, most of the electronic balances are accurate to that value. And before taking the final reading, we wait for the reading on the display to become steady. So you might have noticed whenever you go to the supermarket, we're going to use that example again and again, that whenever they're weighing any of the things you have bought, the reading on the balance actually flickers a bit, it goes up and down, and there's a point when it gets steady and it gets fixed and it does not change. So that final reading is the actual reading you have to take. Such as we can see here, here's some sort of, I don't know, maybe butter or margarine, or I don't know, maybe a bag which contains grain. Whatever it is, we can see here that whenever we place it on this balance, there may be some of the air around here which it will be measuring, and also some of the force our hand is exerting. So we must just, just for our precaution, we just put that, and we wait for the reading here to get balanced, to get steady. And when it gets steady, that's the actual mass we're going to read. So moving on, the measurement of volume. What is volume? Volume is simply the amount of space any substance or material occupies. So, for example, you have a table inside your home, and it occupies, for example, let's say half of your living room. So that's basically its volume. And even though that's not exactly the definition of volume, but you can have an idea according to the example. So it is usually measured in centimeters cube or decimeters cube, which are the basic, divisions which we'll be reading in our syllabus. And another important conversion: 1 decimeter cube is equal to 1,000 centimeters cube. So volume can be measured in a laboratory using many different methods, like taking dimensions for regular objects. Let's say, for example, you have a solid cube. So you can simply measure its length, its width, and its height, and that you multiply all those values using a formula, and then you can have the volume of that cube. And for irregular objects, such as, for example, you can say a stone, so you do not have any specific area where you can measure the length, the width, and the mass of that cube. So you use concepts such as buoyancy, which is using different ways for measuring liquids volumes and gas volumes. So buoyancy basically involves taking a measuring cylinder, you add some water inside it, and then the stone actually lifts up. So there are different methods which we'll be looking at soon, whenever we're solving the questions and looking at the actual content of the past papers. So as you can see here, these are some of the apparatus for measuring volume. And this is a gas syringe. This is used for the measurement of gas volumes. So volume is an important quantity when it comes to determining the concentration and amount of substance. Just like we discussed before, mass is also important, and similarly, volume is actually a quantity that goes hand in hand with mass. So when most probably you'll see that whenever you're measuring mass, you'll also be measuring volume to find out the density or the concentration of the amounts of substance whenever you are performing a chemical reaction, especially in liquids and gases. So the measurement of volume of liquids is done by different apparatus. Liquids have a fixed volume, as we all know. It's the basic states of matter. And to measure volume in liquids, the following apparatus is used. So the first we have the conical flask, which takes a approximate measurement of liquid volumes. However, the use of conical flask is not exactly to measure the amount of volume, but as you can see, its shape is conical, so it's kind of made in a way that the substance inside the conical flask, it cannot come out easily, and that's why it is used for chemical reactions. So whenever you're, for example, you're doing a titration of an acid and alkali, whatever that is, I don't know the exact pronunciation of that word, but whatever it is, you get the point. The conical flask is mostly used for measuring the rates of reaction, as well as other reactions such as the titration, in which we react an acid and a base. And basically reacting literally any substance, we use conical flask because that prevents any of the reactants inside or the products from getting out, and that shall help us preserve the amount of mass and volume inside. Then we have the measuring and graduated cylinder. It's a narrow cylindrical container used to measure the amounts of volume with a moderate accuracy. We cannot say it's too accurate or very lowly accurate, but it usually measures up to 0.1 centimeters cube. So it's basically an instrument for measurement in which we are not so serious about the amount of volume, and we have to measure up to 0.1 centimeters cube. So we use a measuring or graduated cylinder. Then we have a beaker. A beaker is also used for measuring only approximate volumes of liquid, often used to pour solutions into another apparatus. So whenever we have to just exchange the liquid inside or the substance inside, we use a beaker, and we use approximate measurements to do that. So that's what a beaker is used for. There's not much special detail about that. So next we have the burette, which is the most accurate apparatus to measure the liquid volume. And that's because the readings or the graduations on the burette, they are very, very accurate, up to 0.01 centimeters cube. So we actually have a really, we know that how much liquid we are using, and in experiments such as the acid-base titration again, where we need to know the exact concentration of the one of the substances, then burette is very useful because we have to have a very accurate measurement of volume in that. So there is actually a little tiny tab at the bottom, and we turn that, and it actually lets a little amount of liquid to go, below whatever instrument you have there. And it actually, the readings come from zero on the top to the maximum at the bottom. So that's actually the reverse of, for example, what we looked at before. So here we have zero at the bottom, and then we increase our graduations. However, in the burette, we have the opposite. So it starts from zero from above, so that we know the amount of liquid that is lost whenever we open the tap. And next, coming to the pipette, there are different types of pipettes and are used to measure fixed amounts of liquid volumes, such as 25 centimeters cubed or 50 centimeters cubed of a solution, usually for conducting proper chemical reactions. So basically, what pipette is used for, you use a little pipette bulb. It's an instrument you use. You put it above the pipette, and it actually measured fixed amounts of volume. So let's say, for example, you have to measure exactly 25 centimeters cubed of an acid. So you use a pipette. You just click the bulb, and it takes in and sucks in all the acid from any other container you have, such as a beaker, and then you pour it into actual, for example, the conical flask if you want to react it with any base. So you put that inside the conical flask, and you just click the bulb again, and exactly 25 centimeters cube of acid goes inside. So that's basically a way of ensuring that we have a fixed amount of volume that goes from one instrument to another using a pipette. Then we have the volumetric flask. It's basically a simple version of conical flask, a much more precise version of conical flask, and it also measures fixed volumes such as 50 centimeters cube, 100, 125, 250, or whatever. According to the question, you will know the amount of volume to use. And basically, it's used in reactions which involve heating to a specific temperature. So that's because the glass of this volumetric flask is stronger. In all of the instruments we looked at before, such as the graduator cylinder, the beaker, the conical flask, and even the burette and pipette, the glass used is actually quite fragile, and if you heat to temperatures, really high temperatures, it can break down, and that is a hazard. So we use volumetric flask for high temperatures, so that because the glass by which it is made from is actually very strong, so it does not break down. Finally, the measurement of volume of gases. We have, as we know that according to the kinetic particle theory, that gases do not have a fixed volume. They occupy the entire volume of their container. So at room temperature and pressure, a mole of gas occupies a fixed volume of 24 decimeters cubed. So, as we all know that the volume of gases is not fixed, and in order to measure the maximum amount of volume, we use actually a constant which says that a single mole of gas occupies a fixed volume of 24 decimeter cube. No matter what gas that is, it's neon, it's xenon, it's argon, it's nitrogen, it's oxygen, whatever gas that is. If there's one mole of that gas, it will always occupy 24 decimeters cube. And knowing that basic fact about gases, which we'll be looking at stoichiometry, the chapter number 4 or 5, I guess, later, we also have to look at some of the apparatus that's used to measure gas. So first we have a gas syringe, which can be used to calculate the amount of gas produced in a reaction accurately. So let's say, for example, like we were discussing the example of acid and base, acid and base titration, and for example, we have a conical flask in which we are doing that. So we can attach a gas syringe to that conical flask and get an accurate amount of volume for whatever gas we produce, usually carbon dioxide or hydrogen. So basically what I mean is that gas syringe can be used to measure the volumes really accurately up to 100 centimeters cube. That's the maximum amount, the maximum reading we have on the gas syringe. And we have a gas jar, which is often used in quantitative analysis. It's not so accurate. We also use test tubes, but gas jars are basically used to collect gases that are denser than air. So for example, we have a gas that is denser than air. So that basically goes down because, as we all know, according to the basic concepts of physics, that the denser material always goes to the downward, to the where the gravity is attracting it, and the lighter gases, they always go up. So if you have a heavier gas, we place the gas jar in this position, so the gas goes inside and stays below. And if the gas is lighter, we just invert that and it goes up, and we have the gas in the gas jar. However, we cannot approximately measure the amount of volume, because obviously there is no way of telling if the volume is accurate. because there may be some of the atmosphere or air inside as well. So that's not accurate. If you want to accurately measure the gas, it's the gas syringe that we use. So that was it for the subtopic of measurement from the chapter experimental chemistry. We also have another subtopics from the chapter experimental chemistry, which we'll be looking at the upcoming lectures. So thanks for watching. Stay tuned for more videos. Illuminate Education System and your instructor, Muhammad bin Faisal, in and out.